Okay, these first two problems are verifying identities. So we give you something to begin with, and we want to make it look like that, right, at the end. So we need to do some of our tricks and things that we have learned. Number one being replace everything with sine and cosine. Okay, so there are two things on here that are not sine and cosine to begin with. The first being the secant, and the second being the tangent. So we will replace secant and tangent with their respective sine and cosine things. Now that that's done, let's look at what we have. We have a fraction with a denominator of cosine, and here I have a fraction times a number. So basically, fraction plus fraction with the same denominators is perfectly okay to do. So we're going to do sine times sine on top, which is sine squared, and 1 minus that all over cosine. Now that we're here, I can replace my 1 minus sine squared with its Pythagorean identity. Hopefully you remember 1 minus sine squared is the same as cosine squared. Just like that. Now mathematically we can cancel one of these cosines on top with one of the cosines on bottom. And there just happens to be one cosine on bottom, so that leaves us with a straight up cosine. So our answer says we want it to be 1 over secant, and if you remember, the cosine is the reciprocal of the secant. So cosine and 1 over secant are the same. And then we have verified this identity. Now number two, if we remember our tricky trick about fractions, is that if we can add fractions, that means we can also split them apart. So we're going to split this into 1 over sine plus cosine over sine, right? We're doing the exact opposite of what we just did a second ago. When we have a plus in the numerator, we can separate this single fraction into the sum of two fractions. Okay, one of our very rarely talked about properties of fractions. So now we're going to use our reciprocals. The sine is the reciprocal of the cosecant, and cosine over sine is the tangent quotient, the cotan, and that's exactly what we want our problem to look like. Okay, so when we verify, you're taking what you're given and you're trying to make the left side look like the right side. Okay, the bottom section wants us to solve these things. So we want to get our theta by itself, and we'll do it a couple different ways. The easy math comes first. So we'll, of course, add 1 to both sides, giving me 2 sine squareds equals positive 1. And then divide by 2 both sides, giving me sine squared equals 1/2. And now to get rid of the square, we are going to square root. And something we must always remember, when we square root one of these things, you get positive and negative values. Okay, so also part of our algebra is if we take the square root of a fraction, we can root the top and root the bottom separately. So now we can root the top and bottom, so we get 1 over root 2, which we know can't stay like that. So when we rationalize, we end up getting plus and minus root 2 over 2. Okay, so we're looking for all the places on the unit circle where the sign is root 2 over 2. Okay, so you make your unit circle, or you look at your super chart, or you just remember that this happens at all of the 45 degrees. So positive pi over 4 is where it's root 2, and then 3 pi over 4 is also a positive spot. But then it's negative at 5 pi over 4, and it's also a negative at 7 pi over 4. So all of these angles are where we are going to find some place where the sign is either positive or negative root 2 over 2. Okay, this problem we have a secant and a sine squared equals secant. So what we're going to do is we're going to subtract the secant onto one side, so all of our trigs are together. So secant sine squared minus secant equals 0. Okay, now both of these terms have a secant as a common multiplier, so we're going to common factor out the secant, leaving us with a sine squared and a minus 1. Because when we distribute back in, secant times sine squared, and secant has to multiply by something in order to get this minus secant here. So we have secant times sine squared minus 1. So now that we are multiplying, we can take each of these factors and set them equal to 0 so that we can solve. So the secant can never be 0 because secant doesn't ever cross the x-axis, right? It's the upward parabola and the downward parabola. So this doesn't give us any solutions. So all of our solutions will come from sine squared minus 1. So let's add 1 to both sides. Sine squared equals positive 1. And now when we square root, once again, we get both positive and negatives. So we're looking for everywhere on the unit circle where the sign is positive and negative 1. Okay? The sign is positive 1 at pi over 2. And the sign is negative 1 at 3 pi over 2. Okay, so these are your specific solutions between 0 and 2 pi. And if we're going to write it generally, we would add this. So this would be your general solution, because every pi over 2 sign is going to be either positive 1 or negative 1. So in general, if we add 180 degrees, aka pi radians, to pi over 2, you will end up at another place where the sign is positive or negative 1. Okay, number 5 is very similar to what we do when we're solving an application problem. Right? We have to do all this stuff to get everything away from theta. So we get rid of the plus 1. So we have 2 sine 6 times all this stuff now equals negative 1. And now we divide by 2 because that's the next thing we need to get rid of. So I have the sine of 6 theta minus pi over 6's. Okay, and now you might be tempted to divide by 6, but no, right? There's something even farther away, and that's the sine. So we have to get rid of sine first before we can divide by 6. And we get rid of sine by taking the inverse. This is how we get rid of trig, is by taking the inverse of it. So I am sitting here at 6 times theta minus pi over 6 equals, where is the first angle on your unit circle where the sine is negative 1/2? Okay, and that happens at 7 pi over 6. So at 7 pi over 6, the sine is negative 1/2. Okay, now we have an angle equals an angle. And we can continue by dividing both sides by 6. And rather than dividing a fraction by a number, I multiply by the reciprocal. We don't want to divide 7/6 by 6, rather we multiply by the reciprocal. And that gives me, right now that my 6 is gone, sorry, that should not be equal to, that should be a minus. Seven pi over 36, because 6 times 6 is 36. Now my last step is to add pi over 6 to both sides to get it away from theta. Now hopefully you know we can't add fractions unless they have the same bottoms. So this one is a 36. That means I have to multiply this one by 6 over 6 in order to make the denominator into 36 also. Okay, I am multiplying the top and bottom by 6 over 6, which is why the bottom's now 36. So 7 pi plus 6 pi is 13 pi over 36. Okay, now that's only one answer because there's another place on the unit circle where the sign is also negative 1/2, okay, other than 7 pi over 6. So let's go back over here to this part of our equation and plug in our second angle where the sign is negative 1/2. And that happens at 11 pi over 6. And we do the same thing from here. You divide both sides by 6. Then we're going to add pi over 6. I did it again. This is 11 pi over 36. And now I add my pi over 6 again. So 6 pi over 36, 11 plus 6 is 17 pi over 36. So this is the second spot on your unit circle that will make that a true statement. 13 pi over 36 and 17 pi over 36. The first step here is to get rid of secant, and we do that by taking the inverse secant. So we're going to inverse secant both sides. Okay, that's how we get rid of the trig. So now we have this pi over 10 times x equals. Okay, so now we turn our brains on for real. And you need to think about all the places on your unit circle where the secant is root 2. Okay, hopefully you know, maybe you don't, but maybe you might. That happens at wherever the cosine is root 2 over 2. The secant is regular root 2 when cosine is root 2 over 2. Okay, so one of those places that happens is pi over 4 plus 2 pi n. Okay, this is where we throw in the general solution right now before we start doing anything with your x. So the other one would be pi over 10x equals, the other place where it's positive, that would be 7 pi over 4 plus 2 pi n. Okay, this here, once you get rid of your secant and you plug in your angle, this is where we add in the general solution stuff into this part. Okay, so now let's go back. Now that we have that in there, we can figure out what's going on here. So we're going to multiply everything by 10 in order to get rid of my denominator. Okay, so that still has pi x equals 10 pi over 4 plus 20 pi n. And now I'm going to divide everything by pi. Divide by pi, divide by pi, divide by pi. Right, so all the pi's cancel out in all of my numbers. So x equals 10 divided by 4, as I believe 2.5, plus 20n. So the first answer is 2.5. And then the second answer would be 22.5, right? Because I'm adding 20 to this one. And the third answer would be 42.5, because that's what 2 times 20 is. So you multiply 20 times whatever number and then add 2.5 to it. But the first answer is at 2.5. Okay, now let's go back over here and do a similar type thing with our other side. We're going to multiply by 10 and divide by pi all at the same time because I think you can handle it. Mostly because all the pi's do is cancel out. So 70, right? 10 times 7 is 70. 70 divided by 4 is 17.5. Right, that's half of 35. Plus 20n. So our first answer comes at 17.5, and then all the other answers come by adding 20 to 17.5. Okay, so this is what it takes to do a general solution is you add in that 2 pi n after you put in the angle, right? Here's the angle where the secant is root 2, and then we add in the general stuff. Okay, here's the other angle where the secant is root 2, and we add in the general stuff. Okay. I guess the only other answer would be 17.5 minus 20 if you wanted to go around the negative side and get negative 2.5. Okay, and number 8, solving. This one is going to be done by factoring. So if we have a 2 sine squared x, that means we must multiply 2 sine x by 1 sine x. So these are the first things in your factors. Okay, and then the second one is what numbers multiply to give you 1? And those are, of course, the numbers 1 and 1. And since all of our signs are plus, that means our signs in your factors are plus also. So we have 2 sine plus 1 and sine plus 1. So we're going to take both of our factors and set them equal to 0 and solve. Okay, so here we get sine x equals negative 1/2, or we get sine x equals negative 1. So we want to think about everywhere on the unit circle where the sign is negative 1/2. And that happens at 7 pi over 6 and 11 pi over 6. Are the two places where sine is negative 1/2. Now, there's only one place where the sign is negative 1, and that's at 3 pi over 2. So these would be your 3 solutions on your interval from 0 to 2 pi.